Hello everyone, welcome to Mathify. Today we are going to learn a very interesting topic, Introduction to Trigonometry. So before starting, I want to recall and discuss the learning objectives of this learning session. So by the end of this lesson, you will be able to understand the need for trigonometry, identify the parts of a right triangle, define 6 trigonometric ratios, find the trigonometric ratios of an acute angle and understand the basic trigonometric identities. Okay? So let's recall. What is a triangle? So, a triangle is a closed two-dimensional polygon formed by connecting three non-collinear points. What is non-collinear points? The points which are not in a straight line. So, a triangle is formed by a closed two-dimensional polygon formed by connecting three non-collinear points in a plane with the straight line segments. So you can see this AB, if I am saying, so this AB, BC and AC are forming this closed polygon which is known as a triangle. Now what is a right angle triangle? What is a right angle triangle? So a right angle triangle is a triangle in which exactly one interior angle measures 90 degrees. So here you can see this angle ABC. Angle ABC measures how much? 90 degree. So that means this is a right angle triangle. What is the longest side in a right angle triangle? So the side opposite to angle 90 degree angle, always longest side. So which side is opposite to this 90 degree angle? This side. Side AC is the longest side. Now name the side of the triangle shown. How many sides are there? 3 sides are there. What are the sides? Side AB, side BC and side AC. Okay? Okay. So let's continue with the introduction. So here we have you can see there is an activity 1 of Qutub Minar. So suppose you are standing in front of a tall monument like a Qutub Minar. Can we measure its height directly with the measuring tape? Can we measure this height with the measuring tape directly? No. So is there any mathematical way to find its height? Yes, definitely there is a mathematical way. So what is a mathematical way? So the situation can be represented as a right angle triangle. You can see this Qutub Minar is forming a 90 degree with the base, with the distance between you and the Qutub Minar. So this is forming a right angle triangle. Here you can see this right angle triangle is formed APB. If we know the distance D is the distance between you and the Qutub Minar, and the angle theta, this angle theta is the angle of elevation. Okay. So, and then we can find the height h. What is the height? The height of the Qutub Minar. So if we know this the distance between you and the Qutub Minar and the angle of elevation, that is APB, then we can find this height of the Qutub Minar. So this is where trigonometry helps. Okay. Now activity 2, width of a river. So a girl is standing on the balcony of a house located on the bank of a river. You can see here. She looks down at a flower pot placed on a stair of a temple on the other bank. You can see these are the stairs. There is a flower pot on the on the stairs of the temple. Now can she find the width of the river without crossing it? Can she find the height? Can she find the width of the river? This width, this. Can she find it out? Yes. So by forming a right angle triangle, here you can see she is standing here. The stairs are here. So this is with the balcony to the width, these ABC is forming a right angle triangle. So, if the height of the balcony AB and the angle of depression, what is the angle of depression? The angle at which she is looking downward, this angle. So, this is the angle of, this angle theta is angle of depression. If these angles are known, then can we find the width of the river BC? Yes. With the help of trigonometry, we can find the height of the width of the river BC. Okay, so it is possible with the help of trigonometry. Now, there are some more real life situations where trigonometry is used in our everyday life. So, if you want to find the height of the tree, you can easily find it out by making a right angle triangle. In the same way, for the height of the lighthouse, for the height of the mountain, for the height of the aeroplane to the then you can also find the height of the cranes, the satellites and antennas. Now, coming in all these, what do you observe in all these situations? What do you observe? A right angle triangle is formed. In all the previous situations, you can here see the right angle triangle is formed. We use trigonometry to find unknown sides or angles. So, why do we use trigonometry? To find the unknown sides or angles. If we want to find the unknown sides and angles, then we can use the trigonometry. But the condition is there should be a right angled triangle. Okay. Now, what is trigonometry? So, basically, trigonometry is made up of three word segments like tri, gon, metry. What is the meaning of tri? Tri means three. Gon means angles and metry means measurement. So, trigonometry is the branch of mathematics that deals with the relationship between the sides and angles of a right angle triangle. So, trigonometry is basically a relationship between the sides and angles of a right angled triangle. Now, come to the history of trigonometry. Now, ancient Egyptians and Babylonians used early trigonometric ideas. Okay, so Greek mathematicians Hipparchus is known as the father of trigonometry. Indian mathematician Aryabhat made significant contribution and introduced sine tables. Today, trigonometry is essential in science, engineering, technology and many fields. Okay. Now let us discuss the parts of a right triangle. Now consider right triangle ABC. Here you can see triangle ABC is a right angle triangle which is right angled at B. It is right angled at B. Now here hypotenuse AB, AC. This AC is known as the hypotenuse, which I have already told you, it is the longest side of the right angle triangle. So, this side AC is known as hypotenuse. Opposite side of angle A. So, this angle A, this is angle theta. So, which side is opposite of angle A? Side BC. Side BC is opposite of angle A. Adjacent side of angle A. Which side is adjacent to angle A? Side AB is adjacent to angle A. You can see adjacent means जो लगी हुई हो. So कौन सी side angle A से बिल्कुल जुड़ी हुई है? Side AB. So this is known as adjacent side. और कौन सी side angle A से बिल्कुल opposite है? Which side is just opposite to angle A? Side BC. Okay. So these are the three parts: the opposite side, the adjacent sides and the hypotenuse. You can also say the opposite side to the perpendicular to angle A. And this is also known as the base for angle A. Okay. Now, do opposite and adjacent side change? Yes, they change with the angle. If we change the angle, the adjacent side and opposite side will also change. Okay. So, for angle A, if we consider this for angle A, if angle A is theta, okay, if angle A is theta, then for this side, this AB will become adjacent side and this BC will become opposite side. But for angle C, that is phi, this side will become the opposite side. Which side is opposite? Side AB is opposite. And which side is adjacent? Side BC is adjacent. So, and the main part is this, that hypotenuse will remain same. Always remember that hypotenuse will always remain same, but with the change of angle, this adjacent side and the opposite side changes according to the angle. Okay. So, why do we use ratios? Now, look at these two right angles. They have the same angle theta. For example, you are here and your friend is here. So, suppose you are looking to point C and she is looking at point alpha. Okay. So, this is A, B and C. This is alpha, beta and gamma. So, you can see, do you see any pattern? Yeah, the ratio of sides are same. You can see, if I find 5 by AC upon, if I find the ratio of AC upon BC, what is this ratio? 5 by 3. And if I find alpha gamma upon alpha beta, what I find? 10 by 6. That is only, if we simplify, we get 5 by 3. In the same way, if you find the ratio of BC to AB, this is 3 by 4. In the same way, if we find alpha beta by beta gamma, we find 6 by 8, that is nothing but 3 by 4. So, the ratios of sides are the same. That is why we use ratios in trigonometry, because the ratios will always remain same. Okay, if the angle theta is same, here you can see this angle theta is same. That's why the ratio will become same. Okay, that's why in trigonometry we use ratios. Okay, now there are 6 trigonometric ratios. Now, we have already discussed about the right angle triangle. This is the hypotenuse, this is the opposite BC and this is adjacent side to the angle theta. Now, there are 6 trigonometric ratios: sin theta, cos theta, tan theta, cosec theta, sec theta and cot theta. Now, what is this sin theta? Sin theta is opposite over hypotenuse. Opposite over hypotenuse. Cos theta is adjacent over hypotenuse. Tan theta is opposite over adjacent. Cosec theta is hypotenuse over opposite. Sec theta is hypotenuse over adjacent. Cot theta is adjacent over opposite. But it is very difficult to learn this, na? No, it is not actually, because we have a trick. So, here is the trick. You can learn it by SOHCAHTOA. SOHCAHTOA is basically, so is representing sine, for sine is opposite upon hypotenuse. So, Ka means cos is equals to, cos theta is equals to adjacent upon hypotenuse. Okay, and toa means tan theta is equals to opposite over adjacent. Okay, So these are the three ratios which are very important. So you can learn it by SOHCAHTOA. We have another one also, like sum. This is the trick to remember these ratios. Some old horse caught another horse taking oats away. So some old horse, S for sine, O for opposite, H for hypotenuse. So some old horse. Caught another horse means C for cos, A for adjacent, H for hypotenuse. Taking oats away. T for tan, O for opposite, A for adjacent. So some old horse caught another horse taking oats away. You can learn by this also, and you can learn by SOHCAHTOA. Okay. Now, if you learn these three ratios, you can easily find these another three ratios, because these other three ratios are just reciprocals of the sine, cos and tan. So cosec theta is basically 1 upon sine theta, sec theta is 1 upon cos theta, and cot theta is 1 over tan theta. Okay. Now let's do example 1. Now in a right triangle, sides are in the ratio 3:4:5. Opposite is to adjacent is to hypotenuse. Find all 6 trigonometric ratios. So how we are going to find it out? So we have this triangle with us, with the side 3, 5 and 4, A, B, C. So sine theta is basically opposite to the hypotenuse. So what is opposite here to theta? This is theta. So what is opposite to theta? 3 over what is hypotenuse? 5. So here you can see 3/5. In the same way, we find cos theta and tan theta. What is cos theta? Adjacent to hypotenuse. What is adjacent here? 4. Side BC is adjacent, na? And hypotenuse is AC. So what is hypotenuse? Okay. Tan theta is opposite upon adjacent. Taking oats away, that is oats away, O upon over A. So oats means opposite. What is opposite? AB. So 3 over adjacent means 4. Now we can easily find out cosec theta now. Cosec theta is nothing but 1 upon sine theta. So what is sine theta? 1 over 3/5, that will give you 5 over 3. Next is sec theta. Sec theta nothing but 1 upon cos theta, that is 1 over 4/5, that is 5/4. And last is cot theta, that is 1 up over tan theta. It will give you 1 over 3 by 4 and it will become 4 over 3. So, here are your all 6 ratios. Okay. Now, in the same way you can do this question. In the same way you have to find all the 6 trigonometric ratios. This question is for you. Now, example 3. Given sin theta is equals to 8 by 17, find the remaining trigonometric ratio. Now, how will I am going to find this out? Nothing is given here. Yes, it is given here. So, first of all, we in trigonometry we just make a right angle triangle. So, this is a right angle triangle. This is not something wrong. That's fine. So, this side is A, this is B, and this is C. So, this sin theta, let this angle be theta. I am letting this angle be theta. Okay. So, okay, I will write it here. The hypotenuse is AC. The opposite is to angle theta is BC. And the adjacent side is AB. Am I clear? This angle is 90 degree. Okay. So, sin theta is basically what? Sin theta is given here 8 by 17, but according to the formula it is opposite upon hypotenuse. It is given 8 by 17. What is opposite here? Opposite means, opposite here is BC. So, that means this BC is some multiple of 8. So, we will write 8K. And for side hypotenuse, that is AC, it is given that it is 17. So, it is a multiple of 17. Okay. Now, we will find this side. We have to find all the trigonometric ratio. For that, we will find the adjacent side AB. How we are going to find the adjacent side? By using Pythagoras. So, what is the Pythagoras theorem? This AB square plus BC square square is equals to AC square. Okay. So, AB is not given. So, we write as usual, and then BC is given 8K. So, 8K ka square, and square of AC, that is 17, square of 17K. So, what you get? AB square will become 17, square of 17 is 289 minus 8 ka square. 8 square is 64 and we will take K as common. Okay. So, when we subtract it, what we get? 225K square. Since AB square is 225, so AB will be equals to square root of 225. That is, 225K square. That is 15K. Okay. Now we have to find all the ratios. So, this will become 15K. Okay. Now, we have to find all the ratios: cos theta, tan theta, cosec theta, sec theta and cot theta. So according to the figure, ABC, this side is 8, this side is 17, this side is a multiple of 15. So cos theta is basically adjacent upon hypotenuse. So adjacent is, which side is adjacent? 15. This angle is theta, right? So adjacent is 15, 15 over hypotenuse. What is hypotenuse? 17. Now tan theta is opposite over adjacent. Opposite is 8. Adjacent is 15. Cos theta is cosec theta. Cosec theta is just opposite of sin theta. What is sin theta? Sin theta is 1 upon sin theta. Sin theta is given in the question. What is sin theta? 8 upon over 17. So it will become 17 over 8. And sec theta is just opposite or reciprocal of cos theta. So it will give you 15 over 17. And it will become 17 over 15. In the same way, cot theta is just reciprocal of tan theta and it will give you 1 over 8 over 15. That will give you 15 over 8. Okay. So these are the all remaining ratios. Now come to example 4. Example 4. A ladder 13 meter long rests against a wall. The foot of the ladder is 5 meter away from the wall. Find height reached by the ladder, sin theta, cos theta, tan theta, where theta is the angle between the ladder and the ground. So basically a 13 meter long ladder rests against the wall. So let this is the wall and this is the ladder which rests against the wall. So this is 13 meter long. So the foot of the ladder is 5 meter away from the, this is the foot and this is 5 meter away from the wall. So this is 5 meter. So we have to find the height reached by the ladder. So how much height is reached by the ladder? This is, this is A, this is B and this is C. So this is the height H. Okay, the height H, this is BC. So we have to find this and let this is the angle theta. So we have to find sin theta, cos theta and theta. So here theta is given, the angle between the ladder and the ground. This is the ladder and this is the ground. So this is the angle theta. Now first we find the height. So how we are going to find the height? With the help of Pythagoras. So AC square is equals to AB square plus BC square, which is nothing but AB is 5 square and BC is not given. Let BC H. So H square. So AC is given 13. So it is 13 square. So basically 13 square is 25 plus H square. So it will become H square is equals to 25. 13 square is 169 minus 25. 5. So it will become h will become square root of 169 minus 25. It will give you square root of 144, that is 12. So h is basically BC. So BC is equals to h is equals to 12 meter. Okay. Now what we have to find it out? Cos theta, sin theta and tan theta. So sin theta, cos theta and tan theta. So sin theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse and tan theta is opposite over adjacent. So here from the figure it is clear that BC will come out 12 meter, it is 13 meter and it is 5 meter. So this is A, this is B and this is C. So opposite, which side is opposite? Opposite is BC over hypotenuse is AC. This will give you 12 over 13. Adjacent is AB. Hypotenuse is AC. This will give you 5 over 13. In the same way, opposite is BC. Adjacent is AB. This will give you 12 over 5. Okay, so these are the 3 ratios. Now, come to example 5. If angle B and angle Q are acute angles. Acute angles means angles which are less than 90 degree. Such that sin B is equals to sin Q, then prove that angle B is equals to angle Q. What is given? That sin B is equals to sin Q. What we have to prove? That angle B is equals to angle Q. Angle B means this. Angle Q means this. We have to prove that these angles are equal. If sin B is equals to sin Q and B and Q are acute angle, that means less than 90 degree. Here you can see these angles are 90 degree. We have formed a triangle ACB and PRQ. Okay, it is given. Now, let us consider two right triangles. I have already told you about this. What are the two right angle triangles? ABC and PQR, where sin B is equals to sin Q. Okay, so we have sin B. Sin B is how much? Which side is opposite in triangle ABC? For angle B, side AC is opposite and side BC is adjacent. So sin and AB is the hypotenuse. So here sin B will be equals to opposite over hypotenuse. Opposite is AC and hypotenuse is AB. Okay, and sin Q is in for angle Q. For angle Q, opposite is PR and adjacent is QR and hypotenuse is PQ. So opposite is PR, so it will become PR over PQ. Okay. Now since sine B is equals to sine Q, so these two will be equal. That means it will give you that AC upon AB will be equals to PR over PQ. Okay. Let therefore AC, we can write AC over PR. So AC over PR is equals to AB, this AB will goes here and it will become AB over PQ. Let this will be equals to K, let's suppose, say. Okay, now using Pythagoras, BC will be equals to square root of AB square minus AC square and QR. QR is what is QR here? This QR. Okay, and BC is this. So this will be equals to PQ square minus PR square. So basically what we are doing is we just use the ratios. Here you can see it is given that sine B is equals to sine Q. So we got that AC over PR. AC over PR is equals to AB over PQ. So we can show that these two angles are similar. If this BC will be over RQ will also be equals to this, then these two triangles will be similar. So we are just going to show that these two triangles are similar if the ratio of this side and this side will be equals to this. That means K. Okay, so we are just doing this. Sorry. So BC over QR will give you square root of AB square minus AC square over square root of PQ square minus PR square. AB square is nothing. For AB, what we can write here, you can see AB is equals to, for AB we can write KPQ. Okay, and for AC we can write KPR. So I am just writing this K square PQ square minus K square PR square over, I have just converted into PQ and PR only. So it will give you PQ square minus PR square. So this K will come out and it will become K. This K square will come out and it will become K, and it will give you PQ square minus PR square. In denominator you have this PQ square minus PR square. So what it will become? K. Okay, you will cancel out and what you get? You get just K. Okay, so that means this BC over QR is equals to K. So then by SSS, similarity. Theorem, side similarity theorem, triangle ABC is just similar to triangle PRQ, and therefore if these two triangles are similar, it will give you angle B will be equals to angle Q, and that's what we have to prove. Okay. Now come to example 6. Consider triangle ACB right angled at C. So this is right angled at C, in which AB is equals to 29, BC is equals to 21 units, and angle ABC is equals to angle ABC. That means this is equals to theta. Determine the values of cos squared theta plus sin squared theta, and second is cos squared theta minus sin squared theta. Okay. So how will you find it out? First of all, we will find the side AC. How we are going to find side AC? With the help of Pythagoras. So, side AC will be equals to AB square minus BC square. AB is 29 square minus BC is 21 square. So this is a large numbers, so we use the formula 29 minus 21 and 29 plus 21, that is A square minus B square is equals to A minus B and A plus B. Okay. So it will give you 29 minus 21 is 8, and 21 plus 29 is 50. So it will give you 400, and it will become square root of 400 is 20 units. Okay. Now first what we have to find? Cos squared theta plus sin square theta. Cos square theta, cos theta will be equals to, this side will become 20, that means cos theta will become equals to adjacent to hypotenuse, that is 21 over 29 square, and sin theta will be opposite over hypotenuse, so it will become 20 over 29 square, and it will give you 21 square is 441 and 20 square is 400 over 29 square is 841. It will give you 841 over 841, it will give you 1. So cos square theta plus sin square theta will be equals to 1. And now we want to find cos square theta minus sin square theta. So cos square theta will be equals to 21 over 29 square minus sin theta is equals to 20 over 29 square. It will give you, we can solve by 21 plus 20 and 21 minus 20 over 29 square is 841. So 21 plus 20 is 41, and 21 minus 20 is 1. So 841 upon 841. So this is your answer. Now come to example 7. In example 7, in triangle OPQ, OPQ, right angled at P. So this triangle is right angled at P. So right angle triangle is OPQ. OP is equals to 7 centimeter and OQ minus PQ. That means OQ minus PQ is equals to is 1 centimeter. Now determine the value of sin Q and cos Q. So here is the twist. You don't have to find sin O and sin cos O. You have to find sin Q and cos Q. Remember this. Okay. So you have to find this. So for this, what we will do? Here first we find in triangle OPQ, we have OQ square is equals to OP square plus PQ square. OQ square will be equals to this and this. This is the Pythagoras theorem. In the place of OQ, what we can write? 1 plus PQ whole square, and this will become OP square plus PQ square. When we expand this formula, what we get? 1 plus PQ square plus 2PQ, and it will give you OP square plus PQ square. This PQ and this PQ square is cancelled out. What we get? 1 plus 2PQ is equals to OP square, and OP square is nothing but 7 square. So 2PQ will give you 7 square is 49 minus 1, that will be 48. So PQ will be equals to 48 over 2, that is 24 centimeter. So PQ is come out 24 centimeter. Now we find OQ. So OQ is nothing but 1 plus PQ. So 1 plus PQ is 24, that is it will become 25 centimeter. So this side will become 25 centimeter. Now can we find sin Q and cos Q? Yes. Sin Q will become, for this angle, which side is opposite? OP. And which side is hypotenuse? OQ. So OP over OQ is 7 over 25, and cos Q is adjacent is QP or PQ, and hypotenuse is OQ. So QP is 24 centimeter and OQ is 25 centimeter. So these are your sin Q and cos Q. Okay. Okay class, so here we have some basic trigonometric identities. So these are very useful. We will discuss later also. Here are 3 basic trigonometric identities. This is sin square theta plus cos square theta is equals to 1. Second is 1 plus tan square theta is sec square theta, and third is 1 plus cot square theta plus cosec square theta. So remember these 3 basic identities. We will discuss it later in later classes, but for today. So in summary, what we have learned today: the need for trigonometry, parts of right angle, 6 trigonometric ratios, how to find trigonometric ratios, and basic trigonometric identities. Thank you so much class. I hope so you will enjoy my class, and please make sure like, subscribe and share.